So this is our that's our banner, and if you want to look us up on the web, we're TARPN, TARPN. If you look us up on Google, we get the first guy, so you can find us. Okay, so that's me. I've been well, I'm old, and I've been doing the ham radio thing for a while. I have not been doing embedded systems, Raspberry Pis, that kind of stuff, for very long at all. Before I got involved in the TARPN effort, the last time I did any scripting or coding for a Unix or Linux box was on a IBM RSX 4000, I think it was called, in 1990. So my particular work is in small microprocessors, bare metal designs. So I'm nearby, but not exactly there. What happened is in the 80s and 90s, I was involved in a ham radio effort that was a large area geographically. We were building a digital network using modern 1990s technology. And the equipment was really expensive, but everybody in the communications was really desperate to get into this packet radio stuff, and it was a very easy sell, even though it was really expensive. What ended up happening is we built a radio network that was pretty huge, 600 miles wide, 300 miles north to south, 6 states, 3 provinces. It was a big thing. And what happened is that a lot of the participants in the system were actually doing it because communications was a requirement. They wanted to have communications, and the only way to get on the digital networks, the internet as it were, in the 80s was to have your telephone tied up. And hobbyists just generally couldn't do that all the time. At least married hobbyists with children couldn't. And packet radio was a way that at least ham radio operators could get into digital comms and bulletin boards in a 1980s fashion without tying up their telephone line. So when the internet and the cell phone networks came into existence, the ham radio community lost some membership because the people that were into it for communications and not for the love of two-way radio or anything dropped out, and it caused a serious change in how things worked in ham radio, and packet radio really died. Now, one of the things that was true about it was really expensive for what it was compared to the internet. So it was a really hard sell. In the early 2000s, packet radio was just impossible. It went from being inevitable to impossible in a 5-year period, which is really kind of stunning. Now, what changed it all, and why am I here at all talking about something that was big in the 90s? Well, this Raspberry Pi has changed a lot of it, because it used to be that the technology you needed to make a packet radio station was expensive. It cost on an order of $2,000 for an active network node, and half of that was the computer. Well, not anymore. Now you can get a machine that's it's a 2003 quality Windows XP box. It makes that stand up and beg for $35. But you all know that. Okay, so my usual presentation on this, and I've done this maybe 5 times ever, is to ham radio operators. And ham radio operators know all about the two-way radios and know very little about Raspberry Pis. Some of them think that Raspberry Pis are a newfangled idea and that is really kind of cool. Well, okay, that's fine. So I'm going to twist it around and try to sit in the other space. Okay, so the whole point of the communications thing for ham radio is really to get your hands on the basic technology of radio itself. With cellular telephones, we have radio. We carry them around in our pocket. They're wonderful things. In the 70s and the 60s, I grew up with radios that you could take apart with a screwdriver and look inside and figure out how things went. The kids growing up now have these modular boxes that look something like this, and the fact that it's a radio at all is hidden from them. Well, that's a problem. So there's an educational vacuum that's filled by ham radio. This is a toy that lets us actually play with radios and see how they work. Well, the reason why cell phones are such a cool thing isn't so much that they're so powerful and capable, is that they're so cheap for what they are. If you broke it down into individual components and had to buy them all and try to build your own cellular telephone network, it'd be obscenely as expensive. So we're not going to do that, at least not this week. We'll save that for August. What we're doing instead is doing something really juvenile. This is trivial. And we are, in fact, grabbing technology that existed back in the 80s and 90s, and we're using this poor 1.2 gigahertz quad-core processor computer to emulate something that ran just fine on Z80s and 8088s. It seems wrong, but anyway. So one of the things I want to address, this slide is kind of pointing that to me and reminding me, one of the things that's kind of cool with these little computers is making them work together and working with your friends. Because working alone, well, a lot of us can do that, some of us can't. But it's really kind of neat when you can start piling together lots of people, especially people who come from different pursuits. So we have software engineer, we have lawyer, we have farmer, we have cabinet maker, we have metallurgist, we have machinist, we have et cetera. If you get all these people in a room and say, let's make something, you end up with better stuff than if you take 20 people who are Raspberry Pi driver guys. You know, you can imagine what that's like. So what we wanted to do is to see if we could actually build ourselves a network of Raspberry Pis and radios and stuff over an area, well, basically just a bunch of enough of an area to get a bunch of people. So where are you all from? How many people are from, say, Chapel Hill? And how many are from Cary? And how many are from Raleigh and Durham and places outside of 20 miles of here? It's trick to try to take a group that big and say any one of you can talk to any one of the other via radio. Because the only way to do that is to have one of you live in a really nice place in the perch of one of these, quarter-mile high TV towers, or to use somebody else's network. Either that, or you have to have a lot of people in between. Well, a buddy of mine used his mom's house to make a hop, to tie things together. It kind of gets interesting when it's not only the crew of people here trying to build something, but you're now glomming onto people who are innocent bystanders. We have to tie you in. So let's just say we have 5 people, and that's the region we're talking about. That's huge. There's people from Hillsborough and people from East Raleigh. How do you make this go? Well, with Wi-Fi technology, with the 900 megahertz ISM band and so on, throwing antennas up and doing expensive things and borrowing people's towers, it's possible to do this. In fact, if we had WUNC, which is south of Chapel Hill, and WRAL, which is over in south of Knightdale, Garner area, actually I guess it's Auburn. If you had Auburn and Chatham County, those 2 towers, you could do a Wi-Fi link between them. The people who could talk on that network would have to be line of sight with those towers. Well, we could go 900 megahertz ISM band instead of Wi-Fi from the tower to the individual participant, and we could do that. And that's something I really am looking forward to happening. There's actually a large nationwide organization, or lack of organization, called Amateur Radio Emergency Digital Network, ARDN, and that's exactly what they're trying to do. One of the flaws in that, which something that irks me just a little, is that you really have to know somebody to build that network. It's not something egalitarian. You can't just say, well, let's us 5 do it. How do we pull this together? Well, what we did was we took an agglomeration of the digital side, the Raspberry Pis and the ham radios, and we looked at, well, could we do it again like we did back then, only now we're going to use modern technology. How can we cut the cost of this and actually make it possible that someone that's used to a $35 Raspberry Pi as a hobby device moving into a network that cost us over $2,000 per site the last time we did it? And well, turns out there was an answer to that. The Raspberry Pi was a major boon because that cut the costs in half right off. The other thing is that Raspberry Pis have enough horsepower that they can offload some of the things that were done by our Z80 computers before. This little box right here, this is actually a daughter card, a shield card for a Raspberry Pi. And it's a really cheap little microprocessor. It's an 8-bit microchip PIC, and it runs a little modem that's a Bell 202 1970s 1200 baud modem. And this controls a 2-way radio. This is a 2-way radio. This radio was $300 back in the 80s when it was bought for someone's taxi cab. Nowadays, the taxi cab drivers are using cell phones. These things show up on the surplus market for peanuts. Some of them are badly kept because they get shaved out of the marketplace so rapidly that people are just throwing them in bins, and then other people are collecting them and making stacks of them, and they sit out in their barn for 3 years, and then they put them on eBay. And we can get them for as low as $8 a piece, is the cheapest I've seen them. Generally, the known working guy says it's used, it works. There's a guarantee implied by eBay. We'll try to get about $70 for them. Now, back in the 80s and 90s when we were doing packet radio networks, these things cost $400 a piece. So that was part and parcel of our price. So we've just cut the price from $400, well, $300 for the radio. The TNCs were about $150, the modem board, and the computer and so on. And then there's the antennas. Ham radio antennas are bigger than the Wi-Fi antennas. One of the things that makes ham radio actually work better for this application than the Wi-Fi is that the antennas are for a longer wavelength. I don't know if I can get this to everybody. That is a 440 megahertz dipole. Now on a 2.4 gigahertz Wi-Fi system, that's about yay big. This is much bigger, but it's just aluminum. There's nothing high-tech about this thing. This can be made using cut-up Romex, salvaged out of your neighbor's bedroom. Don't tell them. And anyway, that's really low-tech. And in fact, the lower frequency, 145 megahertz ham band, that's a 440 megahertz. The 145 megahertz ham band antennas are 3 times as big, and they cost the same on the retail market. That antenna is probably worth about $30 if you actually bought one new. We can make gain antennas that are 10 dB louder than that. So equivalent of going from 1 watt to 10 watts on the air, plus improving your receiver too. So you're improving in both directions. We can buy one of those new for $70, and they show up used, surplus, sometimes even thrown out. Somebody I know closely recently cleared out someone's crawl space and ended up with about 10 very high gain models of that. 15-foot long jobbers that are 20 dB gain. Really kind of stunning. Well, if you have the capability of making radios, these radios are they're 25 watts. This is on the order of 200 times as powerful as a Wi-Fi transceiver. And with an antenna that is higher capture area, higher gain, etc. Actually, definitely not higher gain than a Wi-Fi directional system, but definitely higher gain than a Wi-Fi Omni. We can actually go pretty far with this. So let me show you what we've done so far. Same scale. Now, I'm actually in North Raleigh. There's 4 little blobs right next to each other. And the reason why they're so close together is because I talk a lot. And I managed to drag some of my neighbors kicking and screaming into this. Further out, if I can, not sure that my mousey here, is that moving? Can you see that up there in the corner? That's Chuck. Say hi, Chuck. So Chuck talks to Adro. Adro talks to First Flight. And First Flight talks to here, to my car. And my car talks to right here. And if I can do this right, and I didn't break things in the meantime, I can get this to work. Now what I'm going to do is I'm going to turn on a pair of walkie-talkies, ham radio specials. And these guys have their speakers on, so we can hear. And what I'm going to do is I'm going to tell this thing to connect to First Flight. And I'm now, what I've done is I've told my packet network here, which is going from the table here, I've told it that I want to establish a command console at First Flight. Now the way, it's not shown on the map here because I just built this like in the last few hours. This talks out to my car, and it's talking out to my car on 441 megahertz. For my car, I'm going on 147 megahertz to First Flight, which is at the north end of Davis Drive by Cornwallis. And then I can tell that I want to connect to Chuck's house. Whoops. It helps to have my keyboard typed right. Anyway, what that's going to do is it's going to go tell First Flight to connect up to Blackwood, and Blackwood's going to go to North Eno Township and get me the command console at Chuck's house. Now, in a second, I'll get on the air, and I'm actually going to drive the thing in and turn it over so that you can watch this, and maybe some of you will come on up here and want to play with this. So, what does this all look like? Well, a Raspberry Pi, here's a Raspberry Pi. Raspberry Pi is hooked up to via a serial cable to one of my little modem cards, and the little modem card has a audio interface that connects up to the transceiver, which is one of these. And the way we're running this, to totally eliminate collisions between the links going in and out of people's houses, we actually are running a separate set of this for each radio path. So when you come back up here and you see that, like let's go up to Chuck's house at the top there. Chuck's got the little black link that goes out to the west. The black links aren't in place, by the way. That's sort of cheating. The black links are things that we're expecting in the next few weeks. The red lines are on 440 megahertz. The blue lines are on 144, and the yellow lines are on 51 megahertz. And as you can see, we're hopping radio frequencies all over the place. Well, this is what it looks like. That was actually my first packet node at my house. And if you count, there's 5 separate transceivers there. And somewhere in the mess in the bottom middle is a Raspberry Pi and a bunch of daughter cards stacked, each one of which has a radio wire going off to there's actually only 3 of those radios hooked up, if you look closely, to the 3 daughter cards. That's what a packet node looked like when I hacked it together. I'm not a carpenter, I'm sorry. This was a better idea. That was actually Finn. Finn Gold lives south of Crabtree, or just north of Crabtree Valley Mall. And Finn has the ability to do wood things. And that's also much more obvious what we're looking at here. So you can see the Raspberry Pi in the lower left. And rather than have the daughter cards stacked on top of the Raspberry Pi, we ran a ribbon cable across them all. And then each one of those modem cards has a DE9 connector coming off the top, and it runs off to a radio. Now, if you look carefully, the left hand of the 3 radios is actually a walkie-talkie. And that walkie-talkie costs around $30 on eBay. It's fully programmable from the top. You can change the frequency with by rotating little thumb wheel switches. And that radio is probably from the mid-'80s. But that was a $300 walkie-talkie when it was new. So anyway, whatever. $30 walkie-talkie, and that's talking 2 miles. And I'll show you his antennas in just a minute. So this is actually another carpented project. This one's definitely much nicer looking than mine. What happened is we attracted 2 carpenters to our project, Finn and Skip, and they did a much better job. Now the TNCs on this one you'll see are green. These were custom made for the TARPN network by Coastal Chipworks. Is a ham up in Buffalo, New York, who was already making these things for a different ham radio project, and we tailored them to our purposes. These red ones are his original ones, and you can actually, on some of them there's modifications made. Okay, so this is an antenna set. Now, to get 20 miles range, you really want antennas that are fairly large. They're not that expensive, but they're fairly large. And you definitely want to get them as high as you can get them, but that's not the crucial thing about this. This mast that's on the top of this office tower, you can see the middle upper picture. There's a mast that's there that actually held a 4-foot diameter dish antenna to link this building to Duke University back in the 80s, I guess, 90s maybe. I saw the mast there when I started working at that building. I'm renting an office on the bottom floor, right below that mast. And I asked the building management if there was anybody using that. No, that hadn't been used for 15, 20 years. You want to take it down? I said, I might. Can I use it? And they said, sure. So I put up my antennas. So I'm at work and I have 5 radios in my office. It's wonderful. This is a different antenna. This is actually Chuck's. Now, Chuck used a slingshot and got a string over the top of that tree, and using 770-pound stress paracord, hauled the antenna up there. And that's high. Chuck's in a really good location, and that tree is just ridiculously high. Now, come back to the Chuck map here. You can see that the 3 links that we're putting in and out of his house, those are fairly long. He can actually go much further than that, because the 2 links, the bottom red one and the blue one, are actually coming off a 20-foot pole right behind his house. The big antenna in the back, we're proposing to move to the link to the left. That has capability that's pretty neat. Now, ostensibly, this was free. Of course, it cost $300,000 to get the antenna or the tree, and the house was free. But this is actually a really neat thing because the neighbors don't even know that it's there. They don't care. It's up in the tree. It's out of sight. It's literally out of sight. It's up there. This is actually not a bad idea for people that live in housing developments, especially if they're old enough to have big trees. Ham radio is really an amazing hobby. Okay, so this is an antenna. This is a commercially bought, brand new arrow antenna. You can buy them any day of the week for $70. And it's about yay long. It's actually the same wavelength as this dipole I was waving around. And in fact, the dipole is electrically the same as the piece that has that connector right here. That's the same as that connector. And that little widget that's hanging below it is called a gamma match. And now, why would you need to know about gamma matches? Well, these aren't really very sophisticated. The measurements are a little bit tight, the tolerances, to make this little piece of magic work, but this can be done with pliers and a soldering iron. And one could build an antenna. Now, one of the things that's neat about the arrow antenna is it's very robust and rugged. It's all solid aluminum tubing and a very nice heavy square aluminum boom. But if this was going in someone's attic, for example, this thing could be made of baling twine and Scotch tape. The wind's not going to pull it apart. This is like building stuff for the moon. It's in your attic. You don't have to have robust antennas. They just have to be electrically right. And this is all part of the hobby. Building antennas. How many of you thought you'd be building antennas next week? Anyway, this is a thing. So we talked about the cost of this thing. This is kind of it. I mean, it's really detailed, but the bottom line is I think that we can build nodes to get people started. We need two ends of a link. So two ends of a link are probably going to cost on the order of $300. Now, you got to know that the people that are involved in this, especially me, are rabid addicts, and we tend to collect the junk. Some of the solutions, like I said, we've been cost cutting this thing because we can. One of the things that you need to run these mobile radios is a taxi cab or a dump truck. This wants to run on 12 volts or 13.8 volts if the motor's running. Well, you need a power supply to run this. Well, it's not a 5-volt wall wart either. Yes? Okay, this wants to have about 7 amps transmit, but that's pretty cool. Keep an eye on that. I want to tell you what we did, though. This, some of you have been around servers. You know what this is. It's a server power supply from an HP server that they've discontinued. These things showed up on eBay by the pallet load for $23, including shipping. This is a 70 amp power supply. This is ridiculous. This will run 6 of these radios in full power transmit continuously, and it barely gets warm when in the normal service. There's a problem with these, and which will make it so that some hams won't want to glom onto them immediately because they do put out a little bit of noise in the shortwave space. And one of the things that hams are wont to do is to talk to distant countries. And I suspect that anybody who lives in a housing development won't ever notice that noise because there's so much poo already in the airspace. But if you live out in the woods and have your 2,000-foot beverage long antennas strewn out all around your property, you probably aren't going to want one of these in your house. But basically, if I can get one of these things, I can turn it around for about $1 and turn it into the equivalent of a $300 power supply. So that's a savings. This, well, let's see. All right, so we'll go on with that. I'll take that in a minute. Okay, so that's actually my end slide, which is kind of cool because now we can have question and answer and I can do a demonstration. But before I do that, I wanted to tell you about some custom projects. Now, the group that is TARPN, there's probably 50 of us. There's maybe 15 that are fairly rabid active involved in this right now. But one of the things that we are is a collection of different disciplines. This is a custom circuit board. W4RFQ actually did the layout and ordered the boards and stuffed them. What it is it's a 12 volt or so input, actually anything from 9 to 20 power supply. And what it does is it has multiple inputs. It's got a battery input. It's actually a battery I/O and a 13.8 volt from our main supply input. And then it has a USB connector. And this little board that's actually plugged in here is a module, this one, which comes from Far East for $2 on eBay. It's a switcher supply. So rather than make our own 5-volt regulator, we just bought these and glue them on. And what this does is it has a dialogue with the Raspberry Pi via a ribbon cable connected to its GPIOs, and it asks the Raspberry Pi if it's okay. Raspberry Pi says, I'm okay, good. If the power goes out, the device will keep the Raspberry Pi floated on its gel cell. This blob here is a gel cell. and that's actually rescued from a UPS after a swap out, so basically free. And it will tell the Raspberry Pi that it's got to be shut down. And the Raspberry Pi has a service running under Linux that sees the input from a GPIO and says, oh, I better shut down. So it drives an output that says, hey, I'm going down now, and which actually we light one of the lights on here that says Raspberry Pi sees that it's in trouble, is going down. When the Raspberry Pi tri-states its GPIO outputs, which is what it does when the Broadcom CPU shuts down, this board with this big FET yanks the power to the switcher supply, thus turning off the Raspberry Pi. This little processor is a little microchip PIC, and it draws microwatts. So while the main power is out, the whole system is down to microwatts level. Main power comes back, the microchip says, were we supposed to be running? Kick the Raspberry Pi back on and watch and see that it comes up. Now it's flashing. I love lights. This thing's got way too many lights, right? It's flashing the lights, telling you what it's doing. This also gives you an on-off button. Raspberry Pis should have an on-off button. So you hit the off button and the Raspberry Pi goes through its shutdown procedure, and then this yanks the power. We hit the on button, it turns the power back on and watches the Raspberry Pi come up. Now, this is, would you think, well, everybody should have one of these on the Raspberry Pi. Well, believe it or not, we went off in a really deep end way. This thing runs on 12 volts. The only people that would ever want one of these things are ham radio operators who have Raspberry Pis. Oh, well, I'm not really that great at an entrepreneur after all. I might have thought of that. Anyway, we have a couple of other products. One of the things we're coming up with is a modem. We actually have a working modem, G8BPQ, not G8BPQ, W4RFQ. Steve lives in Bahama. Do I have a map? Where's Bahama? Boop-a-doop-a-doop-a-doop-a-doop. Boop. Bahama. White blob at the top. That's where Steve lives. Steve is working on a really cool little modem that also will plug into the audio ins and outs of our little radios, so we can retrofit our systems without having to buy all the radios over again. And he's pretty sure it'll do at least 4800 baud through the microphone jacks on the radio. And some of these radios have connectors inside which bypass the audio preemphasis and deemphasis, and we can get 9600 out of them. So we're crossing our fingers to see what it does. Now that's using these radios. What we really want is to get enough people involved in our project who want better radios that we can do a project and actually build some. What we're going to build is not as good as Wi-Fi, but it will have penetration like these do. So we can do a network that's 100 miles wide with impunity. And then we can, but then we'll have something faster than 9600. We're looking for, say again? Well, these things are really kind of good. But anyway, the thing is, we can build our own little transceiver with a Scilabs or a ChipCon radio chip with our own PA and so on. Conceivably, for $200-ish, we could have a 25-watt radio like one of these that does 56 kilobaud. And that's kind of the thing that we're aiming for. But we need people. We need size. And that's where we're going with this. The applications that run on this. So let's switch. I'm going to kill this now, and I'm going to go and run to. I'm going to switch my Wi-Fi's to demo node Wi-Fi. Boop. You will connect. You will connect. Now this is a user interface that John Wiseman wrote in England. And what this does, I'm not sure you can see that. It's too narrow. I lost my video? Okay, let me fix that. Boop. Do we have video? Yay, okay. So this is the command interface for TTDemo. TTDemo is this Raspberry Pi. Now the packet network that we've built is almost like a children's programming language. This is, I mean, it's capable like you would expect the machine to be, but it's really trivial. There's very little automation here. It knows about the network nodes that are within 5 radio hops away. So if we have a network that reaches from the coast to the mountains, which is kind of what we're going for, you're going to have to know a lot about the network to make this go, which is a good thing because we're kind of an irresponsible hobby network and pieces can drop out. So learning how the system works, learning who runs it, being part of the community is what this is about. This is actually designed it's not designed for education. It just happens to be pretty good at that. One of the things you can do at each site, for example, is you can say, well, what are you? Who are you? Who are you talking to? What's your intent? What's your purposes? and you can actually get a list of the, this is a list of the routes that this node knows about. Well, it knows about KA2DEW-8, and KA2DEW-8 is TT-car, and I can say, well, I want to move my command processor to TT-car. And so it says, okay, I'm going to connect you to TT-car, boop. And now I can say TT-car, he says TADS car mobile. And I can ask it what it does. Now, just for the sake of sound effects here, let's turn these two guys on. Now, this radio is listening, you shut up. Boop. This radio right here is listening to the link between this thing and the car. So if I do that command, okay, it's talking to the car. This radio over here, this is the link between my car and first flight. So I'm going to say, okay, get me first flight. And you can see from the screen, well, we're on first flight. Now at first flight, I can say, who do you know about for links? And there's 3 of them. There you go. And now the little chevron in the first column tells you that link is been used. There's traffic has gone on it. There's a bunch of other details, including the call sign of each of the stations that are on there. But one of the things I can ask this thing is, how would you get to TT demo? And it's going to say, the way to TT demo is through KA2DEW-8. And KA2DEW-8 is TT car, as you can see a little higher up the screen. Okay, this is very trivial. Now, what this software that we're running on the Raspberry Pi, that written by John Wiseman, what its purpose is to be an API for trivial servers. And the servers have been written for it since the 80s. There's a bunch of them out there. There's a roundtable chat node. There's a bulletin board program. There's a spotting network, which is made for people to announce, hey, I heard this shortwave station over here. We can write software. The APIs are really trivial. We can write programs in C or Python or even Bash that talk to the APIs. One of the programs that K4VNC, Billy, who's the station, I put the little map back up on here. Billy is over here. You see that? Yeah. Okay. He is. He wants to put a satellite transceiver there and watch the International Space Station. And if you connect to the Billy satellite link, what it's going to tell you is the next time the International Space Station is over the horizon at his house. So it'll give you a countdown in hours, minutes, and whatever. And it'll also tell you how long the pass is going to be. In other words, how many minutes it's going to be visible. When the International Space Station is visible, the plan is that it's going to take all the traffic that it sees off of that. Again, it's at 1200 baud. This isn't very fast. We're going to see 50 lines of traffic off of the International Space Station at most. But you'll be able to see the stations trying to talk to each other through the packet system that's on the ISS. Now, the implication or the idea is that having seen that people are actually making contacts and seeing how far away they are bouncing off of a 250-mile high platform that's cruising on by at 17,000 miles an hour, you can say, well, that doesn't seem that hard. I'll just do this, this, and this, and I'll talk to it myself. And then you can see your packets coming back through Billy's house. This just seems something that, let's go for some enthusiasm with that. So what we have 12 network nodes that are up now. We have the ability to add links to the network nodes. A lot of them are expandable. Some of them have multiple radios that aren't being used. For example, the Skip site, which is Skip right here. Skip is not, can I zoom in on that? No. Skip is has got 3 radios and only one of them's in use. And he is located in between 15501 and where 54 crosses to go down to Chapel Hill. First Flight has 5 radios, and of which 3 are in use. Chuck has notionally 5 antennas on the system, and there's only 2 radios in use. We have an idea of what to do with 2 more, but it's only an idea. There is lots of room to add people into this thing, and the group, the hams, they're actually thinking about it. Chuck and I, who else? I think we may be the only 2. Well, no, Finn down in at Crabtree Valley Mall. The 3 of us are the only 3 that are ever likely to create a program for a Raspberry Pi that are in the group now. All the rest of these people are radio heads, carpenters, machinists, satellite enthusiasts, something. We're an interesting group of people, but we're not embedded systems programmers in practice. There's a lot of room for participation and changing everything. Now, the software we're writing or running is the GAPPQ software is all published. It's not open source in the GitHub kind of fashion. It's really kind of crude because the people who are doing this are not embedded systems people. It could become that way. Now, there's a lot of tools and widgets on Linux that make room for using this kind of TNC over the radio, even with the protocol we're using. In practice, it's generally directed at people who are using internet and want to add a ham radio dimension to it. One of the tenets of our organization, and this is important to anybody that wants to participate, TARPN's purpose is to build a ham radio off-the-grid network. Now, we use internet all over the place to chat back and forth with each other, to download software, to configure things. One of the rules that we make is any traffic that goes over the radios between the network nodes is generated by hand or hand copied. So we will take data that we put on the network and transmit it a dozen times, and we'll copy and paste text documents. Oh, we should put this someplace so someone can get at it. We should paste this and send it. But there's always a human in between the two networks. And the reason why that is because internet traffic in practice tends to be really, really large compared to what we can afford to transmit. We're looking at a network throughput of around between 40 and 80 characters per second between our links. So imagine if someone just grabs the National Weather Service, throws this document out, and it's 60K. It'll go over the network in a couple milliseconds if you're on the internet. Well, it may take a little while on our network, and that would kind of saturate it. Now, the point of this is we get to play. The way that the network works right now is very trivial. It's not very verbose. It's kind of cryptic. It's small. But you can go on here, and you can actually make 30 radios do your bidding. And you can watch them do it, and you can see the effects when they fail. So it's not for everybody. It isn't. But this is a way we started this conversation with 5 guys sitting in a room saying we should make a network between our houses. Okay, if you're all in the same neighborhood, this can be done. Well, with ham radio, we can do this even though we're over many counties. And I'd really like to make it so that the people who go to the Charlotte Linux convention can see our network. Well, how many radios is that going to take? A whole bunch. This is going to be a kick. The first time we show up at one of these places, like Charlotte's got a packet network. Now, the Mecklenburg Amateur Radio Society, Mars, on Mars, they have packet radio that's internet connected. You can actually get on the internet, connect to KF7LLF, Seth's house, and get on the packet radio in Mecklenburg Amateur Radio Society's little, what's a big network. I mean, they have stuff in Winston-Salem, but their network is all last mile to the internet. Almost all the traffic that is there wouldn't be, the traffic on the bulletin boards that are connected to the packet radio running GAPPQ code would be too large of files to be able to even read in a reasonable amount of time over packet. And their network isn't growing. Ours is. There's some philosophical question about if we're doing the right thing. Is this the way you grow your network? Is growing the network the idea? Well, yes, I say it is. I think that we're building something that's different. It's neat. It's fun to play with. Now, I mentioned something earlier. There's a network called an idea, I guess. It is become network in several places called Amateur Radio Emergency Digital Network, ARDN. ARDN is one of a class of broadband ham nets. And what they do is they take off-the-shelf devices of the Wi-Fi kind. They change the software and put them onto bands that are not in the ISM band. They're actually ham radio spectrum. And they're allowed to run more power. They're allowed to run a different frequency hopping schedule. They can put amplifiers on them, and they're building tower to tower to tower networks that are very fast. You can get Ubiquity hardware, download the ARDN software, and put it on there. Change the Wi-Fi channel to -1. Sneaky, goes to -1, and now you are actually on a very quiet channel. It's actually kind of cool, and that's another kind of amateur radio toying that I really advocate. It's a neat idea. The advantage that TARPN has over Arden is that we're using low frequencies and we can go further. Another advantage is that TARPN insists that all of the network hardware is visible. When you go look at someone's node site, you can see where his links go. On Arden, you're on TCP IP. You get to do a trace route. That's the most you're going to find out. There's no public access to everybody's routes tables. Okay, to each his own. This is different. This is than that, and that's okay. I really think we're going to have both here. I bet 10 years from now we'll have an Arden network that works really well. One of the things I really want to see is all of the ham radio FM repeaters that currently link back and forth to each other on the internet, which I despise, would be linked on the Arden system. And I think that would be really cool. So that's what we're doing. And what I can show you here is how we're doing it, how we're building it. One of the other things we wanted to talk about, Mike. You there, Mike? Mike recently got his ham license. The license which is necessary for building a system like this is the lowest level of license that the FCC gives to ham radio operators. With the technician class license on the VHF spectrum, you're allowed to run 1,500 watts transmit power. You're allowed to talk to satellites. You can do weak signal stuff. You can bounce things off the moon. There's all sorts of things. The powers that are available are pretty much limited to the things that do not impact the rest of the world. Shortwave is one of the things that you don't get to do with the technician class license. At least not much shortwave. There's a little limited piece, baby steps. Anyway, with the technician class license, you can run this stuff. I had a technician class license for 12 years. I didn't upgrade until I political snafu. I actually joined a radio club as an officer, and they made me an officer and figured that since I'd been around for so many years, I had to have been a general class or higher. Only when they found out that I wasn't, they insisted that I go and upgrade, and I managed to pass the first try. Hanging around with geeks like me for 12 years, you learn that stuff, I guess. It's osmosis. Anyway, getting a ham license isn't hard. If you go to the TARPN website, let me do that right now. In fact, there's a couple things I probably ought to do. I ought to ask for questions, because that's something that's always good to open the conversation a little bit. I'm not on the right network. Get on RTP guest. Boop. Any questions? Yes? Well, actually, we're just looking for volunteers for that. What we really want to do, and that's important, is we want to make sure that every packet radio node that goes onto our network is ham controlled in a ham accessible space, which means that if you have the key and you want to build it, you've just arrived. One thing we don't want to do is try to put stuff in secure environments like the top of the Brink House Bullet building in downtown Chapel Hill. We were offered a 20-odd story floor to put a node up, and that would have really made a lot of this a lot easier, because then we could have, instead of having all these hop through everybody's houses, we could have just gone up to this 200-odd foot tall building on the top of Chapel Hill. It's not a ham facility. We couldn't get in without an escort. That was the first killer. In fact, that was probably the only killer. It would have been very difficult to that would have, basically that would blow the whole egalitarian thing out of the water. It's like, well, only the right people can do that one. That's no fun. It's much more fun if everybody's on the same floor. Of course, it's also really hard, because now we have to find people every 10 miles who want to link this around. But good question, and yeah, we should do that. That sounds like fun. And it would be a good place to put a demo up. I'll help any way I can. By the way, any of you guys, if you want to get involved in this thing, I'm going to make it as easy as I can. And one of the things I've been doing is whenever a radio, my first one of these radios, I paid like $70 for it. A month later, someone was selling 6 of them for $100. It was worth $70 a month ago. How can it possibly not be worth $13 now? So of course I bought them all. Eventually you have a bunch of these things and they start building up, and you have to come up with a real good justification. So when one of you all wants one of these, or 5, bring it on. The kits we're kind of stuck with. They're $43. Actually, if you come on the website, on the TARPN website, there's actually a shopping list here. It says something like node shopping list. And it talks about what you need to make one of these things work. And one of them is TNC pies. Boop. Am I on here? Good. TNC Pi general info kit ordering and assembly page. And this tells you how to recognize what you've bought, and that is the good button, the one that looks like a PayPal button. Yes. Very good question. This can certainly be emulated in a sound card. For $9, you can buy a sound card, USB adapter device for your Raspberry Pi, and there's a project called Direwolf. If you search DIREWOLF, Direwolf software runs in the Raspberry Pi, and you can have 3 instances of Direwolf running. As far as I know, there's a limit. I don't know why. Each one of which can run to its own sound card and talk to your radio. Now, one of the things I really thought would be kind of cool with Direwolf was we could get Raspberry Pi Zeros for $5 and run Direwolf on each one of them. The sound card plus Direwolf plus a USB serial adapter plugged into the UART on the Raspberry Pi. Say again? Because the analog to digital capability or digital analog capability in the Raspberry Pi isn't up to it. You do need the sound card for the D to A and the A to D. It's just that's the cheapest way to add that. You could do it with an D to A and an A to D port and do it custom, but someone already makes a little widget. They sell them in Hong Kong for $9, and it's like, pff, forget that. And the guys who wrote the Direwolf software say, use this one. So I'm willing to go with that until someone wants to write their own. But anyway, the reason why we're using these things is because they're reliable as heck. They don't crash. We can have as many of them as we want. It's totally scalable. The configuration of each one is just like the other one. If we run 3 Direwolves, you have all sorts of little things that are different between them. It can certainly be done, and Direwolves crash. That's another problem, is that the software doesn't run forever. The G8 BPQ with these things runs for years. So there's a matter of, it isn't ready yet, but I think that we're getting there. But the Raspberry Pi Zero idea was wonderful. It's just you can't buy Raspberry Pi Zeros in any quantity. I couldn't point the website to it and say, click there. So basically, yes, there's other ways to do this, and you all are a crowd that have inputs into this in ways that none of the people in our group do now. Well, at least not very many of us. So yeah, this could go someplace. I would love to have 5 Pi Zeros in my hand at once. For $25, that'd be easy, but I can't get them on demand, and that's crazy talk. So until they come on demand, I can't really tell everybody, go do this. I don't know. Send me a link, please. Newark, you said? You said Newark? Okay. Okay, yeah, I didn't know they were available. Last time I looked, they weren't. So that's another thing that I'd love for somebody else to take on. Yeah, I know about that. That just doubles the price and doesn't help us in this particular application. But what I want to do is I want to take a Pi. What I want to. So what I want to do is make a Pi Zero into a TNC, and it should cost $25, and it will be a better TNC than this is. That's my hope, because then we can, if you can make it so it plugs into USB into the Raspberry Pi, then it's trivial to have 4 of them without even looking at the thing, and that's enough. Right now, none of the node sites are running more than 4 radios. We had 6 at one point, but it was that the problem is you end up with a star network that's incredibly fragile, and you really want to have the network be a circle or a bunch of circles. So 3 radios or 4 radios is probably going to keep most people happy. And heck, hubs aren't that ridiculous. If you're going to run a separate serial interface, it's not like you're plugging in a hub with the audio cards, which according to Direwolf is bad. Audio card, Raspberry Pi Zero, TTL off of the expansion connector on the Raspberry Pi Zero over to the Raspberry Pi 3, which becomes your node hub or whatever. Anyway, there's lots of room for this to go. And I'd like to get some people coming in and trying this. Another one of the things that I find important, only because I'm the stuckee on some of this, is I want to make it so that if you come up with a solution and you want it deployed, that you can actually deploy it. We need to be able to make it so that everybody can do this. And if the next 50 people want your solution, I don't want them to run into bottlenecks like, oh, the damn things just aren't available, or it didn't really work for more than an hour a row, or something. QA is important here. Okay, so that's how you get the TNC. What was the other thing I was going to show you? Oh yes, TARPN. If you go back to the home page here, there's a blue button that says Amateur Radio. And I tried to make it so that, okay, let's go to the TARPN website, please. Amateur Radio, boop. That has guides and stuff, how to do things. And anybody that knows anything better about the process and can short circuit it for us to get someone who wants to be a ham and doesn't know anybody to get the right stuff. Now, if you're here in Raleigh, I'm here, Chuck's here, Mike's here. Other people who are hams are here. And we want to, make it as easy as possible. One thing hams are really worried about is the fleeing of the hams for the internet, because the internet is not ham radio, and the whole idea of having people around that know how radios work when in times of trouble is kind of a good idea. And at least that was when I got my ham license. Okay, so the website. One of the things that's on here is our network map, and this is not the same network map you saw before. This one is more of a schematic, and this actually gives you the frequencies everybody's on. So if you have your HT and you say, well, I want to know if I'm within range of Chuck KW4KZ's house, well, you can listen on these two frequencies and hear it brapping once in a while. Every one of these nodes makes a beacon at least every 5 minutes, twice. And if there's traffic, of course, you hear it going back and forth. And that's the schematic. Now, I would like to think that the three guys who have already built packet radio systems and are trying to hook them up will actually get it going soon, and this will continue to grow. The map I was looking at before, let's see if I can do this. No. Okay, so this is kind of my my work toy to keep, so I can keep track of who's doing what to who. And if you click on any of these links, it tells you the frequency and how far they are, or what I knew about them or something, and who the people are, and so on. Anyway, this is, I keep this going. But this, if anybody wants to get on this thing and wants to try and find out, hell, I'll drive over to your house with a radio and find out. But get a ham license. It's kind of fun. The radios are relatively inexpensive if you know who to ask, and you do. So your getting into this hobby is not going to be very expensive. If you want to get on shortwave, I know where those come from too. Getting a shortwave station capable of talking to Asia or Europe, it can be done for $400 or $500, and that's kind of a kick too. So there's all sorts of aspects to this. A ham radio goes from talking to astronauts on the space station, to listening to Apollo 13 when it's on the way back from the moon, to bouncing signals off of passive rocks that are 250,000 miles away, using satellites. There's several amateur satellites now launched by universities, piggybacking as dead weight on various rocket launches. There's actually a satellite that the Saudi university system launched, we call it Saudi Sat 50, and SO50 can be worked with a walkie-talkie and a handheld antenna. So a total investment of a couple $100 worth of gear, and you can actually use a satellite as it goes overhead, and it's kind of a kick. If you go on YouTube and search, you're going to find all sorts of videos on people doing that, and you can get an idea what it actually looks like. In some ways, it's crude and ridiculous. In other ways, it's really a kick. Any other good questions or bad ones? Bad ones? Well, come on up, and I'll show you what I've got, and then we'll get kicked out of here. How long do we have? 9 minutes? Oh, I got half an hour. I mean, this is Pikers. This is easy. I'm pulling this off now. I'm Tad, KA2DEW is my ham call, and TARPN is the name of our organization, and it looks sort of like, whoops, that's not it. Click on the TARPN logo. By the way, this is the user interface that Finn wrote, and it runs as a web service on the Raspberry Pi. You can get on basically with a tablet or with a laptop or anything, and they all run in parallel. Every station that's connected through the web app sees the same information, and it's kind of cool. So TARPN, that's us, TARPN. Terrestrial Amateur Radio Packet Network.